Yeah, good afternoon to one and all. Is this audible? Good afternoon to all. Okay, so let us go into the presentation. So this is a continuation of yesterday's class where we had started the cyclic codes. So I'll just give you a recap on what we had seen last class, second part, which is about cyclic codes. The cyclic codes are the subclass of linear block codes, which can be in a systematic or non-systematic form. In systematic form, the codes are being separated by a semicolon where x, which is the transmitted vector, is a combination of m and c. M is your number of messages or the message bits represented in k, and the c is the check bits measured in q. Q is the number of bits of c. Then we had seen the definition of cyclic codes. A linear code is called as a cyclic code if its cyclic shift of the code vector produces some other code vector. This is your definition. And the cyclic codes has to satisfy the two properties. One is the linearity property, another one is the cyclic property. So the linearity property is that if you do summation or modular 2 addition of any two code vectors, we'll be getting a result. So that result should be also a valid code word or a valid code vector. If that is the case, then it satisfies linearity property. And always the cyclic codes satisfies this linearity property. Then we had seen the definition of cyclic property also. So the shifting of either MSB or shifting of either LSB. You want to shift in left hand side, the left side would be your MSB, the right hand side would be your LSB. So this MSB will move to the LSB's position in left shifting. Whereas in right shifting, the LSB would be shifted to MSB's position. So these are the two different types of cyclic shifts. And even if you do this cyclic shift, if it produces another code word which is also in existence, so then cyclic property is satisfied. So this is what we had seen in yesterday's introduction class to cyclic codes. So now let us see how do we generate the code vectors in non-systematic form. So as we had said earlier, systematic form is that if you write an x code vector, it will be a combination in the series of m is to c. So message followed by check bits, or the message is present. Next, the following bits in appropriate q bits, the check bits will be present. So x is equal to m is to c. So which we call as systematic. We can easily identify where the check bits are present. But whereas in non-systematic form, we don't know where this check bits are present or where the message bits are present. So for that, we'll be using an format for generating this non-systematic forms. So let us assume that M is having messages M0, M1, M2, M3, M4, M5 till Mk minus 1 to Mk minus 2 in sequences. You can see where K represents the number of message bits, the number of bits information of message that is to be transmitted. Then the corresponding polynomial can be written as corresponding polynomial, which is your degree of its place. So m of p is equal to mk minus 1 pk minus 1 plus mk minus 2 pk minus 2 plus mk minus 3 pk minus 3 till m1p m0 p0. So p0 is always 1, so we write it simply as m0, which is the least significant bit, m0. And the most significant bit would be your mk minus 1. Okay. So this can be represented in code vector also. Since x is always a combination of message and check bits, the check bits are written in the form of a generating polynomial, in this case in cyclics. So x of p can be written as m of p into g of p, where m of p is in equation number 3.4.5 and g of p is the generating polynomial of degree q. For example, if you have an n comma k cyclic codes, then our q will be always n minus k. So we can easily find the number of parity bits that is being generated by the polynomial. And the polynomial will be varied from or written as g of p is equal to p power q plus p power q minus 1 into q minus 1 plus p in p of q minus 2, like this. Yes. Into q, so g of q minus 2 plus p of q minus 3 into g of q minus 3 till g of 1 into p plus 1. How do we get this? One is that g naught into p naught. G naught into p naught. G naught is always 1. P power 1 is always 1. So we write it as 1. So the LSB will be always 1 here. Equation 3.4.7. So where this g of q minus 1, g of q minus 2, g of q minus 3 till g1, g naught, all this represents your parity bits. If we have message vectors m1, m2, m3, for example, if you take three message vectors that are being present, then the corresponding code vectors can be generated by simply doing modulo 2 addition with its polynomial. So the polynomial is known generator polynomial. Multiplying with its generator polynomial. So the generator polynomial is your g of p. So if I want to determine x1 of p can be obtained as m1 of p into g of p. If I want to determine x2 of p, m2 of p into g of p. If I want to find x3 of p, m3 of p into g of p, and so on. So these code vectors which are being generated, x1 of p, x2 of p, x3 of p, are all non-systematic in nature, and they satisfy the cyclic property also. And we should also make a note that this generator polynomial g of p will remain same for all the code vectors. Will remain same for all the code vectors. So let us see this with an example. So we take an 7 comma 4 cyclic code. In the question it is given as we need to find all the code vectors in non-systematic form. So the question is the generator polynomial of a 7 comma 4 cyclic code is g of p. The generator polynomial is given as p power 3 plus p plus 1. We need to find all the code vectors for the code in non-systematic form. So from the given question we can find what is the value of n. Since always it is n comma k, so n can be obtained from the given question as n is equal to 7, k is equal to 4, since it is n comma k. So next we need to find q value. So q lies in n minus k. So n is 7, k is 4. So 7 minus 4, which is 3. Now we should see how many possible code vectors can be found. So since there are k is equal to 4, k is equal to 4, 2 power 4 will get the 16 message vectors. So these message vectors will vary from m0, m1, m2, m3. So here it is written m0, m1, m2, m3. So this is a message vectors. So next is that we need to find a message polynomial. We need to find a message polynomial with respect to this equation. Equation number 3.4.5, m of p is equal to mk minus 1 p power k minus 1 plus mk minus 2 p power k minus 2 plus mk minus 3 pk minus 3 till m1 p plus m0. So take that equation. Substitute in that the value of k. So what is k? We had seen that k is obtained from the question as k is equal to 4. So if you substitute k is equal to 4, we get 4 informations of the polynomial. One is m0 into p0, m1 p1, m2 p power 2, m3 p power 3. So m0 p power naught will be getting it as p0 is equal to 1, and m1 p power 1 we can write it in terms of p. So the equation of message polynomial will be for k is equal to 4, m3 p cube plus m2 p square plus m1 p plus m0. So this is your message polynomial. Okay, this is your message polynomial. Now I am taking for example the message of this question. For example, I consider a message vector. I consider a message vector as 0101. So this is for what do you call, for my assumption. So I am taking 0101 as a message vector from the 2 power 4 16 message bits. So I am taking 0 1 0 1. Okay, and now I substitute this 0 1 0 1 in the place of m3 m2 m1 m0 respectively in this m of p, where m of p is m3 p cube plus m2 p square plus m1 p power 1 m0 p power naught. So p power naught is always 1. Okay, so here I substitute this. Instead of m0 I substitute 1. Instead of m1 I substitute 0. Instead of m2 I substitute 1. Instead of m3 I substitute 0. So then when I simplify this, I'll be getting p square plus 1. P square plus 1 is your message polynomial. This when I consider an example of the message vector to be as 0 1 0 1. Now see the question. In the question it is given as g of p. G of p is p power 3 or p cube plus p cube plus p plus 1. So write that equation as it is, whichever is given as your generator polynomial. So you'll be having two equations, equation 3.4.9 and 3.4.10, message polynomial and generator polynomial. So now in the question, we need to find code vectors in non-systematic form. So the non-systematic form code vectors can be obtained by the relation x of p is equal to m of p into g of p. M of p is your p square plus 1. Write it as it is. G of p is p power 3 plus p plus 1. So write it as it is. So after writing this, what we are going to do is that I'll tell you. Just write the m of p that we had obtained. Write the g of p which is being given. Let me check for any questions in the chat box. Then I'll say what to do. Yeah, there is some disturbance from my side. Yes, sure, it is there. I'm outside my house. Yeah, tell me, Tanuja, what doubt? You can type in the chat box. You could hear lots of birds being singing. Yeah, you can ask your question, Tanuja. No, in code vector x will have 7 bits. For this problem you're asking. Okay, let me see the question again. I'll show you the question again. Yeah, you're asking about the message vector. Okay. So how did I write this message vector is that I had taken the value of k. So in non-systematic form, the representation of messages or the message vector is always represented in m1, m2, m3, m4 till mk minus 1. So now here in this problem, the k value is 4. In this problem, k value is 4. So if it is 4, since the k value is 4, we get m naught m1, m2, m3. No, the assumption that you're saying message vector will be 7 bits. No, it's not message vector, it is your code vector. Code vector, I'll type it. Code vector is equal to 7, which is n. And in the given question, it is n comma k. So in resemblance to the problem, it is 7 comma 4. So what do we get? We get the total length of the code vector as 7, and the number of messages in that is 4, and q is equal to n minus k, which is 7 minus 4 is equal to 3. Okay. Any other doubts? Okay. I think you are getting a confusion between the message vector and the code vector. No issues. When you practice, you will get it easily. Don't worry. X, capital X, is always your code vector. M, capital M, is your message vector. C, that's what capital C is your check bits. Or checking vectors. So X can be given as X1, X2, X3 till Xn. Whereas this message is written in M. So M1, M2, M3 till Mk. Check bits are written in C. So C1, C2, C3 till CQ. So have a differentiation. If you have a differentiation, it will be easier for you. Okay. Now we had obtained M of P. We had obtained G of P. Now C M of P. M of P is P square plus 1. G of P, P cube plus P plus 1. Simply do multiplication. Do multiplication. If you do multiplication, P square into P cube, we get P power 5. Why? Because all the power should be summed up in multiplication. In division, the power should be subtracted. So we get P power 5. Then P3 with P square is P power 5. P3 with 1 is P3. Then P with P square. Yeah, I'll start from the beginning. Okay. P3 into P square is P power 5. So P3 into 1 will be P3. Then next P into P square will be P power 3. P into 1 will be P. And 1 into 1 will be 1. So it is written here in this first. P power 5, P3 plus P square plus P cube plus P plus 1. So here P cube and P cube are repeated. So bring it together. So P power 5 plus P power 3 plus P power 3 plus P power 2 plus P power 1 plus 1. Now what we are going to do is that In p power 3, we are going to take 1 p power 3. So 2 p power 3s are there. So I'm going to take this p power 3 as common outside. So remaining will be 1 and 1. So we can do the modulo addition of these two. Since these two are present with the same polynomials of power, it will become 0, because 1 modulo 2 addition 1 will be 0. So into p power 3 we get it as 0. So the remaining will be p power 5, p power 2 plus p plus 1. We will get p power 5, p power 2 plus p plus 1. So this equation I am rewriting in degrees of polynomial. I am going to write in terms of degrees of polynomial. So how I am going to write is that here we don't have just a minute, I'll tell you. Here, since our length of the code vector, for example, we are determining what? We are determining our x value. So x is a combination of m and g. So it's not moving. Yeah. X of p is the combination obtained from m of p and g of p. So what is our x value? X value is your number of bits of n. So since n is equal to 7, x also will be 7. So we should write in terms of all the 7 values. Okay. So this p power 5 plus p square plus p plus 1, there are only 4 elements. Here we have p power naught. That position is having 1. Here in p power 1 we are having a position 1. Here in p power 2 we are having a position 1. But p power 3 is not present. So in that place we are writing 0. So 0 p power 3. P power 4 is not there. So 0 into p power 4. In p power 5 we have p power 5. So we are writing as it is p power 5. So we don't have p power 6. So we are writing 0 into p power 6. Now when we count all these things, 1, 2, 3, 4, 5, 6, 7. 7 bits of information will be present. 7 bits of information will be present. When you see, I had written the x value. So x value ranges from x6, x5, x4, x3, x2, x1, x0. So they see this equation and write what we have in the place of x0. We have 1. In place of x1 we have 1p. So write 1. In place of x2 we have p power 2. So p2 is present. So 1. 1 into p2. So write 1. We don't have in p power 3. So x3 will be 0. In the place of p power 4 we don't have anything. So it is 0. So x4 will be 0. In the place of p5 we have 1. So in x5 you need to write 1. In the place of p power 6 we are having 0. So write x6 is equal to 0. And we need to keep in mind that the degree of polynomial will be always 1 minus the n value. So since n is equal to 7, the degree of polynomial will end till x, sorry not x, p power 6. And that is p power 0, p power 1, p power 2, p power 3, p power 4, p power 5, p power 6. So now, how do we find the code vectors? Is that I had taken an example of what is my message? I'll show you my message. I had taken 0101. This is my message. And I had done, and I'm writing it correspondingly. See here, M0, M1, M2, M3. See in this, where is 0101? 01, which is serial number 3. 0101. So the equivalent non-systematic code vector is this. You can see a 0 1 double 0 triple 1, 0 1 double 0 triple 1. Similarly, we need to do it for the remaining message bits also. Remaining message bits also. Now for the remaining message bits, you are going to do and tell me whether you're getting these answers correctly or not. You're going to check and tell me. So before that, I will explain you the next thing which is to be determined. Okay. So the next thing is to determine is that whether this bit is a cyclic or not. Okay. So to check whether this is a cyclic or not, right, take down the same value. Okay. Take down that same value. Where is it? For example, which value? 101100. I'm taking okay. So from the table, I'm taking a value of x8. It is not xg. Please wait. It's not x8. Okay, x9. So I consider a code vector from the table 101100. I take that and I do cyclic shift by left side. So if the example is 101100, I do a cyclic shift in left side. So if I do like cyclic shift in left side, what will happen? This LSB will move to the next MSB. This MSB will move into next MSB. This to next, this to next, this to next, this to next. So what about the MSB which is present? So that MSB will go in a cyclic fashion to the LSB. So it will come here. So if it comes, what will happen is that you will get a vector. So 0 1 1 0 0 1 1. So this 0 triple 1, sorry, 0 double 1 triple 0 1 is present for another code. This 0 double 1 triple 0 1 which you have obtained after cyclic shift by 1 bit position is also an code vector present in your table. Okay. So I'll show you this. It's also present. Now, what you all are going to do is that you are going to take message bits of this table and you are going to check and tell me whether you are getting these answers correctly or not. You are going to check and tell me whether the corresponding message, this non-systematic code is generated or not. Okay. So if you want, you can make a screenshot of this. Everyone take a screenshot of this. Then in a paper or so, do it and check it. Let me see a screenshot is over. Okay. Yeah, everyone take a screenshot of this slide. I had done for a message called 0101 message. I had found a non-systematic code. Now Similarly, you need to do the same procedure for all the remaining 15 message vectors. Oh, sorry, remaining message bits. Take the screenshot of this. Then take the screenshot of this. Two slides, slide number 6 and slide number 7. Take screenshot. In a paper, you solve and see whether you are getting the corresponding, for this corresponding message bit, this corresponding non-systematic code is generated or not. Okay, let me check for any other questions. Solve in a paper and see and tell me immediately. Okay, as you solve it, I'll give some time for solving. Take screenshot of slide 6 and 7. Take for all the combinations of message bits to generate non-systematic codes. I'll keep the slide again. You can take the screenshot of slide 6 then slide 7. After 2 or 3 minutes, I'll change it to slide 7. So meanwhile, take the screenshot of this slide 6. I hope everyone would have taken the screenshot of this. I'll move on to the next slide that you can take the screenshot. Make a note of this, and for every message bits, you find whether you're getting this non-systematic code vectors. Always our G of P will be same for all the messages. X of P is equal to M of P into G of P. G of P is given in the question. So it will be common for all the message vectors. You need to do only determination of m of p, then multiplying that with g of p. Afterwards, we need to assign for each of the values equivalent x0, x1, x2, x3, x4, x5, x6 values. If the polynomial is present, we need to assign 1. If the corresponding polynomial is not present, we need to assign 0. If you do this, we'll get this non-systematic codes easily. I'll keep this slide for 2 or 3 minutes. Take a screenshot of this and do the practice and give me a feedback whether you're getting it correctly or not now itself. Try it. Why? Because without solving this cyclic codes, it would be very difficult for going for the next level of cyclic codes. So try for at least 4 combinations. So since it is divided into 16, so it is 16 divided into 4. So at least one you can try from each sub blocks. It's enough that if you can write in a paper, you not write in books or notebooks, write in a paper, solve it, and if you find it correctly, just take a photograph that and send it in our WhatsApp group. For doing this, it may take around maximum 10 to 15 minutes, I think so. So I will wait. Let me see for any questions. Shrija, do it for all the codes and see. I'll give you some 10 or 15 minutes time for checking this. Okay. Okay. I'll take, for example, I'll solve one thing. If somebody is unable to understand, you can see this also. I'll take a message 1 0 1 0. I consider that this is the message that I'm going to generate using the generator polynomial g of p. G of p is p cube. I suppose, right? Let me check. P cube plus P plus 1. So M of P, M of P is, how do I write M of P? M of P is M3 P3 plus M2 P2 plus M1 M naught. So this is your format. So in this, I'll be having only two ones. So this one. So we have P3 plus P power 2 is not there. M2 into P2 will be 0. So then P will be there. That's all. Okay. So now I need to do M of P into G of P, which is our X of P, for determining the code vector for the message 1010. Now I'll take another frame such that I can do it easily there. Okay, so here we know what is M of P is P3 P. Okay, P3 plus P into G of 3 is P3 plus P plus 1. So now multiply this P3, multiply this, I'll highlight in red color. P3 with P, P3 with P power 3. Then P with P3, P with this P. Then this one with P3, this one with P. I'll be getting the answer. P3 into P3 is P power 6 plus P3 into P is P power 4 plus, so P3 is what? This P3. So next, this P is there. So P into P3, which is P power 4 plus P into P, P power 2 plus P into, okay, this P is also over. Next, we have with 1. So P3 plus P. So what do we get? This whole will become 0. So remaining are P power 6 plus P power 3 plus P power 2 plus P. So for this, since we have 7 bits, the bits of information can be retrieved by placing ones in this position. So 0 plus P power 1 plus we have P power 2 plus we have P power 3 plus we have P power 4 in 0. So 0 into P power 4 plus p power 5 with 0, p power 6. So this would be your polynomial. This is your polynomial of x of p. So now convert this to messages. So if I convert this to messages, I'll write in red. So 1 0 0 1 1 1 0 1 2 3 4 5 6 7. So how do I write that is? So for p6 I have 1 1 into p power 6. For p power 5, 0 into p power 5. For p power 4, 0 into p power 4. For p power 3, 1 into p power 3. P power 2, 1 into p power 2. So p power 1, 1 into p power 1. So here I don't have p naught or p power 0. So 0. So this is your non-systematic code of the message vector 1010. So for 1010, I should get 1001110. Let me check in the table. Serial number, serial number 11. I'll enlarge it. Serial number 11 is 1010. Here it is 1001110. Let us check in the Jamboard. See 1001110. 1001110. Like this, do for the remaining. Check and tell me. Yeah, there is an additional feature being added in the Google Meet. The direct accession of whiteboard or the Jamboard. So if I click the Jamboard directly, you will be getting the meeting link of the corresponding Jamboard which is opened. I'll show the messages again. What is the message that I had used? Kindly check for all the 16 message bits. Why do you get 16 message bits? Is that due to k is equal to 4. So 2 power 4 we get 16 different message bits. Yeah, Lakshman is there.
Yes, sir.
Lakshman, I
Sir.
have a doubt.
Yes, sir.
In chat box, I sent a link.
Yes, sir.
If you click that, how it appears?
Access denied, sir.
Access is denied
Yes, sir.
for that
I
link.
think you have given the access only for university mail ID, sir.
But you are in university mail ID only now.
Yes, sir. I have joined the meet with university mail ID, but my Chrome is running with my personal mail ID, sir.
Oh, oh, okay, okay. So the browser should be in that mode.
Yes, sir. Yeah.
Okay,
If we change
let me
that,
also check.
the total history and all will be saved in that, sir.
Oh, okay, okay. So this is the first day of the Jamboard, which is being inbuilt with Google user. This is the first day. So I got a
Okay.
doubt.
Yes, sir.
Okay, let me also check it. I'll check it in online also how it goes.
Okay, sir.
But for me, it is coming.
Yes, sir. You only have given, no, sir.
Okay, okay.
Or else let me present, no, sir. I'll show you how it is
Oh,
coming, sir.
okay, okay. Then wait. I'll do that settings also. Just a minute. I'll stop presenting. Then I'll give you permission to present. Then
Okay,
you
sir.
show me
Okay,
how
sir.
it shows. மேலே போக ஆரம்பிச்சிட்டாங்க. Yeah, Lakshman, try to present and click that link. Let me see how it goes.
Sir, can you see my screen, sir?
Yeah, yes, yes. Your screen is visible.
I'm getting like this, sir. I have sent you access this request,
No, no,
sir.
no. You change this. You signed in as that. You change.
Okay, sir.
Bottom it is there. No, that you change. Now choose your. Yeah, choose that. Continue.
Jamboard.
But Jamboard is missing.
Yes, sir. This account I have chosen, sir. My university mail
Yeah, yeah,
ID.
yeah. Okay, choose it. Choose it. Yeah.
I click continue. Just my
Okay. Now go to Jamboard. Open Jamboard in the Google Apps. Now go to Google Apps. Left, right side. Yeah, that one. Only. Click it. Open Jamboard. Okay. Go for recent jams.
there is nothing here, sir.
Okay. Now what you do is that copy from the meeting ID. Copy that and paste it in Jamboard. In Jamboard, you paste it.
Okay, sir.
We'll see. We'll see what happens.
Jamboard in search bar, sir.
Yeah. No, no. At the top, next.
Here, sir.
Yeah.
If we type here
No, you type. We'll see.
like this, it will be there,
No, no,
sir.
no. No. Here your login is in right
Okay,
hand
sir.
side when
Okay.
you see. The login is in out of that.
No, sir, sir. Here my account is there, sir.
That's what.
Yes, sir. My
What
account
you
I
do is
have.
that go for guest option. Hmm. Now you try it again. Let us see.
Yes, sir. Even I came from, yeah, from my Google account I came here, sir. Sir, see, sir.
Okay.
It is opening a Jamboard like this.
Okay. Give a request. Let me see whether it comes to me or not.
Send, sir. Get permission to open a file, sir. Here. You need to give
Okay. To
access,
whom?
sir. Once you need permission,
Okay. So.
click request
Oh,
access.
I should give.
The
Okay. Let
owner
me.
of the file will get it.
Okay. Okay.
Okay, sir.
Let me check it. Let me. Okay. I am checking. Yeah, I'm checking. Wait. Kindly wait. சுப்ரியா மழை வருது பாரு. ம். வெளியே சார்ஜ். Lakshman, now you check your Jamboard, Jamboard whether it is opening. I had given access.
Sir,
Okay, okay, but for everybody, this cannot be given. No, only you can view.
only me, sir.
Yeah, yeah. Okay, next time I'll give you in prayer. Okay. Only after starting the meeting, I was able to see that Jamboard is in inbuilt with Google Meet. So
Sir, I
surely,
can't edit, sir.
no, you cannot edit.
Yeah, sir.
Yeah, you cannot edit.
I can
Only you
see
can
this.
view it. Yeah, you
Yeah,
can
sir.
view it.
Yeah, sir.
Okay, I will type something. Check whether it is appearing in your site.
In second board, sir.
Wait, wait. I'll. You check whether whatever I type that you're getting there.
Sir, are you typing, sir?
Yeah, I think now you are able to see,
Yes,
right?
sir.
Okay, okay. So in some whenever we want to solve problems, I'll send you in advance in either Google Meet or either in WhatsApp. Okay, then you can give me a link for request. If it doesn't comes, then directly you can see in the what do you call Jamboard itself for
Sir,
any
you can
problem.
make open access, no, sir.
Open access means okay. I'll check
It
that
will be
also.
saved in Google Drive, no, sir. This
Okay.
board will be saved in Google Drive, no, sir. In there, if you give open access for all permissions, it will be okay. I think so, sir.
Okay. Okay. I'll try that also.
Okay, sir.
Okay. Thank you, Lakshman. I hope everyone would have checked the message bits for that whether you're getting non-systematic codes or not. So this time you could have used for that, and I'll proceed for the next point. So for the example which I had done 1010, this is the corresponding non-systematic code vector 1001110, so which we had generated. See, 1001110. So 1001110. So now I perform left cyclic shift. Left cyclic shift is that this will come here, 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 this will come here. And what about this value? This value will go to this positioning. So this is the cyclic property. So when we do like this, let us see what happens. So 0, 1, 1, 1, 0, 0, 1. So when you do left cyclic shift, the value will become 0, 0, 1, 0, 1. So see there are 7 bits. 1, 2, 3, 4, 5, 6, 7. So now check whether this cyclic shifted bits are present in the same table somewhere else or not. So 001101, which is a left cyclic shifted bit, this also will be present in the table. Let us see that. So I'll keep a remembrance 001101. So 00. See the fourth one. See the serial number 4. 001101. So fourth one is a non-systematic code vector of 001101. So when we do cyclic shift, that produces a code vector is also present as another code vector. So hence the cyclic shift property is satisfied. Similarly, you can check for the remaining non-systematic code vectors also. If there is any doubts, you can type in the chat box. If you have any doubts in this today's cyclic codes, kindly for check for each and every message vector. Srikala, try for four ones and type in the chat box what answer you are getting. For each and everybody, I'll give you one message vector for the corresponding polynomial. Try to solve and send the answers in chat box. Srikala, 2, 3, 4. For Srikala, it's triple one. Sorry, four ones. For Harsha, 1110. Do for this message polynomial. Harsha, Srikar, Sai Srikar. Yeah. 0001. It will take some 10 or 15 minutes. Don't worry. See the understand the procedure. How do you do it? For Pavan Chandra, I will give you. Pavan Chandra. 1011 for Pavan Chandra. For Naresh, 0011. These are the message vectors that I am giving you. Generator polynomial is the same. P power 3 plus P plus 1. Do it. For Naresh I had given. For Tanuja,
Sir, for non-symmetric
no,
only,
you
sir.
practice. What M of P you are getting, you check it. And find.
Yeah, okay, sir. But that is for non-symmetric method only, sir. You are giving
No,
now.
no, I'm giving message vector. M of P. Message
Yeah,
vector we had
okay.
chosen initially in the presentation I had shown you for 0101.
Yeah, okay, sir. I'm asking methods, sir. For non-symmetric method only, you have to do this.
No, no, I don't want solution. You check and tell me what answer you're getting in chat box. What what
Yeah,
non-systematic code you're getting for this sequences.
yeah, okay, sir. I'm asking that only, sir. Non-symmetric code only how to find, no, sir.
No, you do in a paper, ma.
Okay. Not that,
No,
sir. Yeah, okay, sir. I will do, sir.
no, you do in a paper.
Yeah, okay, sir.
Just a minute, just a minute. You do it in a paper, scan the solution and send in our WhatsApp group afterwards. But what solution,
Yeah,
what
okay,
answer,
sir.
final answer you're getting as the non-systematic code that, for example, Srikala is given with the 4 ones. She has to give for 4 ones what is the corresponding non-systematic code, what she is getting in chat box. The entire solution in WhatsApp group.
Yeah,
Now you
okay,
understood,
sir.
I think so, right?
Yes, sir.
Okay. So for everybody, I am giving you one. Don't worry. For Tanuja, message vector is 0001. Purna Venkat. Purna Venkat Sai. 1110. Okay, already I given. Okay, okay. Sorry, for Purna Venkat Sai, I'm changing. Purna Venkat Sai, already 1110 I had given. So 10, 0, 0. For Purna Venkat Sai, it is 0110. Then Lakshman. For Lakshman, for Lakshman 1010. And for Srija, Srija, for Srija 1000. So now what you do is that in a paper, write these are as your equivalent message vectors, equivalent message vectors. Then our generator polynomial is p power 3 plus p plus 1. Find x of p. Find x of p. Then determine x naught, x1, x2, x3, x4, x5, xx. For all the coefficients, what is the equivalent value of x? Find it. Okay. Srija has done. She has given the value 101100. So you would have done it in a paper, right? So what you do is that take a photo of that. At the top, write your name. Just put it in our class WhatsApp group. Finished. Mention your register number. So Nagalakshmi Srikala has got for a 4 once message vector 1101,001. So what you do is that take a photograph of the solution that you have done, write a register number at the top and put it in our class WhatsApp group. Because these cyclic codes are very important in error detection and correction also. Why? Because if you are able to do this manipulation easily, the next thing is that you need to do it in quotients. So it is a big task. We need to find remainder. We need to find quotient. So depending upon the quotient, divider, dividend, we will be generating the errors. We will be correcting that. Okay, so that's what I'm taking this much time on a single problem in today. I'm waiting for others also to give their answers. Kishore is there? Forgot to assign for Kishore. Kishore left the meeting. Okay. Waiting for other solutions also. Srikala and Srija completed. Okay. Lakshman, you got a 1101,000. Okay. 3, 4, 5, 6, 7. Okay. Scan the solution or take the photograph of the solution. Put it in our class group, such that everyone also can see how is this being done. The cyclic codes plays a very major an important role in error correction and error detection. Whereas the linear block codes can do error detection up to 2, correction up to 1. These cyclic codes are advancement of that. When we want to correct 2 errors in linear block codes, we need to add an additional parity bit, or we need to add an additional extra bit with the existing linear block codes. So that will in turn increase the length of the codes. So rather than that, if you use a cyclic codes and convolutional codes, we can easily correct how many number of errors that is being detected that can be done with an appropriate constraint. For example, I am having the message bits as 7. There are 7 message bits, keep in mind, not 4. I'm assuming that 7 message bits are being transmitted, 7 bits are received. If there are 1 bit, if only 1 bit is being errored, we can easily solve it by using block coding, linear block coding. If 2 bits or 3 bits, we can easily solve by cyclic codes. If 4 bits or 5 bits have been occurred, we can use an advanced convolutional codes to a certain extent. If 80 percentage, or if 5 bits, 6 bits, or 7 bits, all the bits are being errored, though we use an efficient algorithm for retrieving our information, we cannot do it. So in that case, we need to use forward error correction methods or forward error correction mechanisms, or we need to use an appropriate uh, protocolling structures which will ask the sender to transmit the signals again, transmitting of the information again. Okay, so the understanding of cyclic codes polynomial is very essential. Okay, so next Harshavardhan, right? Okay, Harshavardhan 110010. Okay, so the solution, kindly put it up in class group. Okay, message. Yeah, I had seen Srija's answer, Lakshman's answer, then Harshavardhan has to upload. Okay, he'll upload, I think so. Lakshman's answer, okay. Still, Srikar's answer is received. So everyone tried to follow Srikar's format, how he had solved it step by step. If you use that step by step procedure, in future also, if you're solving the same problem, it will be easier for you. Kindly check in WhatsApp group how Srikar has solved it step by step, writing every what do you call information in a sequence. You can follow Srikar's waiting answers for. Okay, Harsha. Harsha, your solution. I'm waiting. Pavan Chandra 10. Pavan Chandra, some I don't think so. Check whether there are 7 bits. It seems like 8 for me. 1, 2, 3, 4, 5, 6, 7, 8 bits you are typed. 10, 5 ones. Sivasai, okay. Okay. Pawan Chandras is correct. Okay. Sivasai is also correct. So when you make a comparison or when you view the table, check whether whatever you had solved matches with the table that I had shown in the presentation. that would have taken as a screenshot. Let me check for solutions. Okay, I think most of them had completed for whom I had given. Okay. So now compare this with the screenshot which you have taken, and kindly everyone type your register number in the chat box for attendance, and you can leave the meeting. In next class, I'll start the in next class I'll start the non-systematic code how to generate using another method. Okay. Thank you.